our goal for today is to be able to find the total angle measure of any polygon. So the first thing we need to be able to do is identify what is a polygon, what consists of a polygon, and we need to learn a few special terms about polygons, okay? So the polygon, when we break down the word poly and gon, we have a prefix and we have a suffix. You guys have heard of prefixes and suffixes, right? Okay? And isn't that amazing? You guys just did some work. Some of you just did some work with that. Okay? The prefix poly. Anybody know what poly means? Yeah? Poly means many. Any idea what gon, the suffix gon means? Yeah?
Angles.
Yes. Many angles is that's how you break down the word. Now a polygon has to be a shape that's fully enclosed, so there can't be any openings. That means all the lines that make up the shape have to be intersect. And where the 2 points intersect, that's called the vertex. And it has to be straight lines. So like an ice cream cone or a cone is not a polygon. In fact, a circle is not a polygon. Because we have to have angles and we have to have straight lines. Okay? So I have a poster right up here of different polygons, and we're going to be looking at all of those polygons today. We'll be naming the polygons, but more importantly, we're going to be able to determine the total angle measure of every polygon by looking at by coming up with a way to find out that, but also we're going to look at a formula and prove why that formula works. Okay, and it'll be the same formula that you get for your MCA test. All right, same formula. You'll see that formula and a few others. I'll pull that up later on today. All right, so we're going to start off. Everybody knows that a square or a rectangle, the sum of all the angles. So when we add up this angle here, plus this angle here, plus this angle here, and this angle here. When we add up those 4 angles, what do we get? Yeah. Well, no, when we add up their angle measures, I'm sorry, when we add up their angle measures. So if we take the measure of this angle, plus the measure of this angle, plus the measure of this angle, plus the measure of this angle, what do we get? Okay, go ahead. 360. 360. Because we have 4 90-degree angles, right? 90 plus 90 plus 90 plus 90, or we can do 90 times 4 and get 360. However, there's even further proof that it's 360. Because if we take one vertice and make sure that each vertice is connected, so you can see right here that this vertice is already connected to this one right here, right? But it's not connected to this one down here. It is connected to this one right here, right? All the vertices are connected. How many triangles do we make? We have 2 triangles. We have one triangle here and a second triangle here. What is the sum of the angles of this triangle? These 3 angles add up to 180. So this is 180. And then this one down here is 180. So that is what we're going to use to determine how many triangles can we draw inside these figures. And that will tell us, because this angle measure right here plus this one here and this one here equals 180. Now we go to the other one and look at how we fully enclose this angle. We say this angle here, and this angle here add up to 180. So we can put those 2 groups of 180 together. Makes sense to everybody? Makes sense to everybody. Okay? So we're going to see if we can find a common pattern. We have 4 sides. The total angle measure is 360 degrees. And how many triangles do we have? 2 triangles. All right, we're going to go on to the next shape. Next shape, it's going to be a 4-sided shape. Or five-sided shape. That was the four-sided. Here's the five-sided shape. Anybody know the name?
Yes. Pentagon.
It's a famous building in Washington, D.C., right?
Yeah.
Pentagon. Five sides. Okay? Five sides. Now, if we take one of the vertices right here and we connect them all, that one's already connected. This one isn't. This one isn't. That one's already connected. We have a grand total of five sides. And how many triangles do we have? Three triangles. Can anybody tell me the sum of all, if we add up all of the angles together, what do we actually get? So when we go like this and say this plus this plus this plus this plus this. Anybody know what the total angle measure of a pentagon is? Yeah. I'm going to say this is 180. This is 180, right? And this is 180. So what can we do to find it all out? Yeah. Add them all together. Okay, so we could go 180 plus 180 plus 180. Oh wait, that's actually 2, isn't it? 540. So that means, now keep in mind, we have to use, to get this angle right here, we have to take this angle from this triangle, plus this angle from that triangle, and that angle from that triangle to get all of it. Okay? Everybody see how we can use these triangles to determine how many, what's the total angle measure? Now, I want to just take it one step further and say this. If that pentagon, the sum of all their angles equals 540. And I'm going to throw out another term that we need to know. It's called a regular polygon. Here's what a regular polygon has. It has all congruent sides. And if all the sides are congruent, guess what? All the angles have to be congruent. Okay? So if this side is congruent to this side, and this side is congruent to all the sides, that means every one of these angles have to be congruent or the same. So what's the angle measure of one angle? If I said right here, I said this is angle B. What is the measure of angle B? I hope we get that yawn on the video, don't you?
Yeah. I woke up at 2.
I hope your mom watches this and can determine that's you.
I never watched videos.
So how would we do it? How would we find just the measure of angle B? The grand total is 540 degrees. How many angles are there? No, how many angles are in this shape?
5.
If there's 5 sides, there better be 5 angles, right? Say it again. I heard somebody say it.
No, I didn't.
Say it again, please. Just repeat what she said then. If the total is 540 and we have 5 individual angles that are all the same, shouldn't we get our answer? So what's the measure of just angle B? What is 540 divided by 5? Do it in your notebook. Do it in your notebook. Mr. Anderson, what'd we get? You are wrong. 540 divided by 5. How many groups of 5 will go into 500?
Oh, he thought it was.
How many 5s will go into 40? So close. The measure of angle B is equal to,
108.
so each one of these angles would be 108 degrees. Does that make sense to everybody? Okay. Now that's taking it the next step. It's getting a little bit harder. If we can find the sum of all the angles, and if we know that every one of those angles are the same, we divide by the number of angles that we have. So if we go back to our very original picture here, didn't erase everything. You can see that we have 1, 2, 3, 4, 5 sides. That means we have 1, 2, 3, 4, 5 angles. And if all of those angles are the same, we should be able to take the total and divide it by 5 to find 1. And that's exactly what we just did there. Okay? But remember, 5 sides, how many triangles?
3.
3 triangles. All right, here's our next one. Anybody know the name of a 6-sided shape? Hexagon. What do you think hex means?
6.
It makes sense. So should there be 6 angles?
Yeah.
Yeah. 1, 2, 3, 4, 5, 6. Now let's see how many. Anybody predict how many triangles we're going to make? For 4 we had 2 triangles. For 5 we had how many triangles?
5.
3. We have 6 here. What do you think?
4.
Well, let's see. I'll choose this vertice right here. Why? That's connected, right?
Mm-hmm.
So we need to connect here.
Yeah.
There's 1 triangle, right? We need to connect here.
Yeah.
That's 2 triangles. We need to connect here. 3. We need to connect. That one's already connected, right? So 6 triangles, or sorry, 6 sides. And how many triangles? 4 triangles. So that means we have, whoops. That means we have 180 here for all of these. Add up 180 right there. We have 180 here. That there, that there, that there. We have 180 here, right here, right here, and right here is 180. And then we have 180 right here. Here, here, and here. So what is the sum of all the angles together? How would we find it? How would we find it? Go ahead. By adding all, now can we do, instead of going 180 plus 180 plus 180, 180 times, because repeated addition is the same thing as multiplication. 180 times 4, and I'm going to do it the opposite way. We'll see if this works. What's 4 times 100? Okay, 400. Whoops. What's 4 times 80?
4 times 80, 320.
It's 320. If we add them together, we get
720.
720 degrees. That means that all of the angles added together add up to 720. We okay with that? Head up, please. Sit up straight. Sit up straight. Sit up straight. Thank you. Now we have a 7-sided figure. 7-sided figure is called a heptagon. 7 sides. Any predictions on number of triangles?
5, 6.
Well, let's go through. Let's see if we can see a pattern. 4 sides gives us 2 triangles. 5 sides gave us 3 triangles. 6 sides give us 4 triangles. So 7 sides would give us any. Do we see the pattern? Here's 1, 2, 3, 4, and 5. Everybody see that? What's the total angle measure? So if we add up this angle here, this angle here, this angle here, 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 and here, what are all of them put together? What do they have to be? 900? How'd you do it? You added, what did you add? Tell me. 180 plus 180 plus 180, 180 plus 180 plus 180 plus 180.
Repeat an addition.
Thank you. 5 groups of 100 is?
500.
5 groups of 80 is?
400.
Grand total of? By the way, do you know I'm actually using the distributive property when I do that?
I know that.
I am. That's basically doing this. 5 times 180, and we say 5 times 100 is 500, plus 5 times 80 is 400. We get a grand total of 900. Okay? We okay on that? All right. Last one, and then we're going to see if we can figure out what this formula is. Okay? Hopefully you see these every day, and hopefully who's ever driving you to school, or if you're riding your bike to school, or even if you're walking to school, you obey this. Otherwise you could get hurt, right? Stop sign. 8 sides. Any prediction on number of triangles? 8 sides, 6 triangles. Should I prove it?
Yes.
Well, he's saying I don't need to prove it. Well, 1, 2, 3, 4, 5, 6. 6 triangles.
I know what it is.
Then to find the sum of the angles, what do we need to do? What do you need to do? Yeah.
Add 180 to 900.
Add 100. Would that work, kids? Yeah, because we said 900 was a 7-sided shape. We have one more triangle, so let's just add 180 to it. 180 plus 900 is 1,080. Now, is there another way to do it? Yeah, Eric.
All the sides minus 2 equal how many triangles there are.
Would we all agree that that's true? Would we all agree that that's true? Eric, can you say that again?
All the sides minus 2 equal all the triangles that are inside of it.
Everybody hear that and understand it? He said he's found it. Look at this. The number of triangles, 4 minus 2 equals 2. The number of triangles is equal to 3 here. 5 sides minus 2. All right.
6 minus 2 equals 4. Oh. 7 minus 2 equals 5. Oh. And then 8 minus 2 equals 6.
Everybody hear that? We see a common pattern there?
Yep.
I guarantee there's going to be something in this formula that says the number of sides discounted by 2 or subtracted by 2. Then does anybody else have an idea of what we can do after we find the number of triangles? What else can we do to find the sum of all the angles?